Hello, and welcome to Philip Brown's Computer Networking Lab. You're watching the instructional video called Static Routes. In this video, we're going to give a very basic explanation of what static routes are and why network administrators would use them to route traffic. Routers do not automatically know how to send information from one part of the network to the other. They must have some type of roadmap to point them to the next destination that the data packets must go in order to get closer to the destination. The roadmap can be created either by manually typing in the directions into the router using static routes, or by having the directions created by having the routers talk to one another in order to communicate with each other their view of the network using dynamic routes. Static routes work well in very small networks, but as a network grows, it becomes difficult to maintain the roadmap. If an administrator needs to change a route in a network consisting of 100 routers, he might have to go to each router and make the change. The command used to create a route is IP route, followed by the network subnet, the subnet mask, and usually the IP address of the router that's supposed to receive the data packet. Here we have two computers in the same local network directly connected to each other through an Ethernet cable. We are able to send a ping packet from computer A to computer B because they are directly connected to each other. When computer B receives the ping packet, it sends a reply packet back to computer A to let computer A know that the ping packet has been received. Now, let's add a router to the network and have computer A ping computer B. Note that both computer A and computer B are on two different network segments with a router joining the networks. I have already assigned the IP address to both the router and the computers. First, the ping packet leaves computer A and travels to the router because the router is the default gateway for computer A. In other words, if a data packet's destination is outside of computer A's local network, computer A will send the packet to the router and allow it to determine the next step in sending the packet to its destination. When the router receives the packet, it knows which interface to send the packet out of because the router is directly connected to the network. The router sends the packet to computer B, and since this is a ping packet, router B will reply to it by sending a reply packet back to the sender, which is computer A. Since the destination of the ping packet is computer A, which is not on computer B's local network, computer B sends a packet to its default gateway, which is the router. The router reads the destination address of the reply packet as being computer A's IP address and sends the packet to computer A. But most networks are not this simple. If a router is not directly connected to a network, the only way it knows how to send the information to that network is if it's manually programmed in by a network administrator using a static route, or if it communicates with other routers to learn the networks they are connected to. As in the previous example, both computer A and computer B are both on different network segments, but this time there are two routers joining the networks. I have already assigned an IP address to both the routers and the computers. Let's try pinging computer B from computer A. First, the ping packet leaves computer A and travels to router 1 because router 1 is the default gateway of computer A. Since computer 1 has no knowledge of which interface leads to the 10.1.3 network, the router drops the packet and sends a reply packet back to computer A telling the computer that B is unreachable. When a router does not know how to get to a specific network, it drops the packet, meaning that it does not send it anywhere, and deletes it. In fact, even if computer A tries to ping computer 2, computer A would fail to get a reply. This is because router 2 has no idea of how to send the reply packet back to router A. The 10.1.1 network is unknown to router 2, and it does not have any default gateways, so it would simply drop the packet. Now, let's type in the IP route command for both routers A and B, so that they will learn which interfaces lead to which unconnected network. If we use computer A to ping computer B, the ping packet will leave computer A and travel to router 1, because router 1 is the default gateway of computer A. When router 1 receives the packet, it knows which interface to send the packet out of because of the static IP route command that we assigned to router 1. Router 1 sends the packet to router 2, and since the network destination is directly connected to router's 2 interface, the ping packet will be sent to computer B. Computer B will respond to the packet by sending a reply packet back to the sender, which is computer A. Since the destination of the reply packet is computer A, which is not on computer B's local network, computer B sends the packet to his own default gateway, which is router 2. Router 2 reads the destination address of the packet and knows to send the packet to the interface directly connected to router 1 because of the static IP route command that we assigned to router 2. And router 1 sends the packet to the directly connected computer A. In this video, we looked at how static routes could be used to give routers information about which interface they should use to forward data packets so that they arrive at their destination. I hope this video was informative, and I thank you for viewing.